Now to get back to energy and transition into forces, we're going to look at a concept that bridges the gap between them and motion. How hard an object will be to stop, how much power it has as a result of its motion, is related to its amount of kinetic energy. This value is called momentum. Sometimes you'll hear it described as how much oomph a moving object has. The more kinetic energy an object has, the more momentum it will have. Comparing the equations for kinetic energy and momentum will make this relationship much clearer. Kinetic energy equals half times mass times velocity squared. Momentum equals mass times velocity. Both are based on the mass and velocity of the object. So if one increases, so will the other. The more momentum an object has, the more force it will exert in a collision. Just like energy is always conserved, but can be transferred from one object to another, momentum is always conserved, but can be transferred. The law of conservation of momentum states that when objects collide, the total amount of momentum remains the same. The momentum of each object can change, because one object may transfer some or all of its momentum to the other object, but the sum or total will remain the same. Think about a game of pool or billiards. Sometimes, when the cue ball hits another ball, it keeps going in the same direction with the object it hit. Sometimes, it will turn around and go in the opposite direction, and sometimes it will stop while the other ball continues on. The cue ball transferred different amounts of its momentum, different amounts of its kinetic energy, to the other ball, making its motion change. The momentum in both balls changed after they collided, but if you added the momentums of the cue ball and the other ball before they collided, that sum should equal the momentum of the two balls after the collision. If you're going to try to predict the momentum of an object after a collision, you would use the following formula, in which m1 means the mass of object 1, m2 means the mass of object 2, v1 means the velocity of object 1, and v2 means the velocity of object 2. The small I and f stand for initial and final, and tell you whether you're talking about that object initially, meaning before the collision, or finally, meaning after the collision. So the formula altogether is m1i times v1i plus m2i times v2i equals m1f times v1f plus m2f times v2f, or the initial mass of object 1 times the initial velocity of object 1 plus the initial mass of object 2 times the initial velocity of object 2 equals the final mass of object 1 times the final velocity of object 1 plus the final mass of object 2 times the final velocity of object 2. You would simply identify the given information from the problem, substitute the values for the variables in the formula, and then solve for the one remaining variable.